You probably know by now that whenever possible, you should be making data driven decisions at workplace. But do you know how to analyze all the data available to you? The good thing is that you don't have to do the number crunching yourself, but you do need to correctly understand and interpret the analysis created or developed by your colleagues. And one of the most important types of data analysis is regression. Regression analysis is a set of statistical methods used for the estimation of relationship between a dependent variable and one or more independent variables, and it can be utilized to assess the strength of the relationship between variables and for modeling the future relationship between them. Today we are going to discuss regression. It refers to the statistical technique of modeling the relationship between variables. A regression model is a mathematical equation that describes the relationship between two or more variables. Actually, there are two types of regression analysis. First is simple regression analysis and second is called multiple regression analysis. In simple linear regression, we model the relationship between two variables. One of the variable denoted by or represented by y, which is called the dependent variable, and the other which is denoted or represents by x is called the independent variable. Secondly, in multiple linear regression, we model the relationship between two independent variables or more and one dependent variable. Actually, the model we basically use to depict the relationship between a dependent variable like y and independent variable x is shown in a straight line relationship where only one independent variable like x relationship between independent and dependent basically described, denoted or reflected by a linear function. Here the changes in y are assumed to be caused by the changes in x like independent variable. And in order to show the graphical relationship, a graphical sketch of the pairs x and y dependent and independent variables is called scattered plot, where we can see and we can show the positive linear relationship, relationship with not linear type of relationship, or negative linear relationship, and no relationship at all. Here we need to discuss and understand the regression model. A simple regression model actually that gives a straight line relationship between two variables, which is basically x and y. It is called a linear regression model. So in that model, y like dependent variable is equivalent to alpha plus beta into x plus e, which is called the y-intercept or constant term. B actually, beta is the slope and e is the random error term. So the dependent and independent variables are y and x respectively. So let's look at an example scenario. For example, you are a sales manager trying to predict next month's numbers or next month's sales. So you know that dozens, perhaps even hundreds of factors from the weather to a competitor's promotion to rumor for a new and improved model that can impact the number, like impact the sale. Perhaps people in your organization even have a theory about what will have the biggest effect on sales, such as, trust me, the more rain we have, the more we sell. Or 6 weeks after the competitor's promotion, sales will jump. So, regression analysis is a way of mathematically sorting out which of those variables does indeed have an impact. It answers the questions: which factor matters the most, which can have ignored, how do those factors interact with each other, and perhaps more importantly, how certain are we about all of these factors. And in regression analysis, these factors are called variables. You have dependent variable, the main factor that you are trying to understand or to predict. In the example above, the dependent variable is the monthly sales, and then you have independent variables, the factors you suspect have an impact on your dependent variable. So, how companies do use it? Actually, regression analysis is the go-to method in analytics, and smart companies use it to make decisions about all sorts of business issues. As managers, we want to figure out how we can impact sales or employee retention or recruiting the best people or personnel. It helps us figure out what we can do. And most companies use regression analysis to explain a phenomena they want to understand. For example, why did customer service calls drop last month? And predict things about the future. For example, what will sales look like over the next 6 months? Or to decide what to do. For example, should we go with this promotion campaign or a different one? Let's take a look at a regression example and its solution using Excel. As an example, let's take sales numbers for umbrellas for the last 24 months and find out the average monthly rainfall for the same period. This example shows how to run regression in Excel by using a special tool included with the Analysis Tool Pack add-in. Analysis Tool Pack is available in all versions of Excel 2019 to 2003, but it's not enabled by default, so you need to run it on manually. So let's run the regression analysis in Microsoft Excel. So in this example, we are going to do a simple linear regression in Excel. So what we have in a list of average monthly rainfall for the last 12 months in column C, which is our independent variable like predictor. And the number of umbrellas sold in column D, which is the dependent variable. Of course, there are many other factors that can affect sale. But for now, we focus only on these two variables. We should carry out the following steps to perform regression analysis in the Excel. So out of the data tab in the analysis group, click the data analysis button, select regression and click OK. So in the regression dialog box, configure the following settings. First of all, select the input Y range, which is our dependent variable. In our case, it is umbrella sales. Then select the input X range, which is our independent variable. In this example, it is the average monthly rainfall. So then check the label box because there are headers at the top of our X and Y ranges. Choose the preferred output option, a new worksheet in our case. So here we will click and then click OK and observe the regression analysis output created by Excel. So we will click at OK in order to see what are the results and output in a new sheet. So how we can interpret the regression analysis output? As you have just seen, running regression analysis in Excel is easy because all calculations are performed automatically. The interpretations of the results is a bit trickier because you need to know what is the behind each number. Below you will find out the breakdown, like you are seeing that 4 major parts of the regression analysis. Like first of all, multiple R. It is the correlation coefficient that measures the strength of a linear relationship between two variables. The correlation coefficient can be any value between -1 and 1, and its absolute value indicates the relationship strength. The larger the absolute value, the stronger the relationship will be. In our case, there is a stronger relationship, like strong relationship between umbrella sale and rainfall, and is as indicated by 0.98 or 98%. Second, R square. It is the coefficient of determination which is used as an indicator of the goodness of fit. It shows how many points fall on the regression line. In our example, R square is 0.97, which is fairly good. It means that 90% of our values fit the regression analysis model. In other words, 97% of the dependent variables or Y values are explained by the dependent variable. Generally, R square of 95% or more is considered as a good fit. Then adjusted R square. It is the R square actually adjusted for the number of independent variables in the model. You will want to see this value instead of R square for multiple regression analysis. Then at the last, standard error. It is another goodness of fit measure that shows the precision of your regression analysis. The smaller the number, the more certain you can be about your regression equation. So in another example, so we have the example that where we need to find the least square regression line for the data of income and food expenditure on the 7 households given in the table. So use the income as an independent variable and food expenditure as a dependent variable or y. Here in the table, income X is given and food expenditure is also given. So what we will do, we have to basically interpretation of A, consider the household with zero income. So first of all, we will run the regression analysis. We will go to the data analysis and then we will select the regression. And here what we need to do, we need to select over X and Y. X is independent and Y is dependent. So X here is the income and Y dependent is our food expenditure. So we will select here and then we have to click at label and new worksheet and click OK. So we will find the results. So what results says actually, we need to see carefully. So how we can interpret? First of all, multiple R. It is the correlation coefficient that measures the strength of a linear relationship between two variables. The correlation coefficient can be any value between -1 and 1 and its absolute value indicates the relationship strength. Second is R square. It is the coefficient of determination which is used as an indicator of the goodness of it. It shows how many points fall on the regression line. And then we need to see adjusted R square. It is the R square adjusted for the number of independent variable in the model and you will want to use this value instead of R square for multiple regression analysis. And standard error similarly. So here what we can conclude, you can see